Hello guys, this is Akash. Welcome back to Nursery with Lecture YouTube channel. In this video, I am going to explain parabola, which is the part of conic sections in the geometry section. That in this elevate batch, I already completed the straight lines and pair of straight lines as well as circles. Now I will complete the parabola in one shot so that the entire concept will be revised for you. And in this JMains 2024 elevate batch, I have already completed the matrices and determinants, complex numbers. So many chapters I already completed. If you want to watch those videos also, it will be available in the playlist section. You can go and watch. Now I will discuss the parabola. Basically, I already said the straight lines and pair of straight lines. After completion, you have to study the circles. Not directly, we have to go to parabola. You have to study the circles. So if you didn't watch the circles video, you can watch the circles video. And after watching the circles video, you have to watch the parabola video, because this parabola, if you watch, the next ellipse and hyperbola will be easy, because the circles, whatever properties we have discussed, the entire properties will be again discussed here. But the radical axis, radical center, there are so many concepts which are not in parabola. But the concepts like a chord with the given midpoint and tangent, slope format, parametric format, everything will be discussed here. So you can watch here. So now I will discuss the parabola. What is a parabola? The shape of the parabola is given in the picture here. You can clearly see this. This is a parabola. This is a parabola, and parabola, in this parabola chapter we are going to discuss 4 equations of parabola, which are very important. But the main important equation is y square is equal to 4ax form. This is very important, and the graph of this y square equal to 4ax is this one only. And what is parabola in the conic sections? When we use the sections, that is, this is a cone and this is the circle we got, and this is the ellipse we got, and this is a parabola we got. How we got this parabola? When we use the plane which is cutting the cone at certain angle, where we got this shape. This shape is called parabola here. So this parabola, for this parabola, we will discuss the properties, we will discuss the tangent and normal equations, everything. But actually, what is parabola? In this parabola, ellipse and hyperbola, we will discuss one concept called eccentricity, E. The eccentricity here is, suppose this is a focus. I will explain what is focus. Suppose there is a point P, and there is a this point is, we can take D, and if we join both PD and PF, their ratio, that is the distance from a fixed line to fixed point, that is PD, that is the eccentricity, that is equal to PD divided by PF. This should be equal to 1. Then only PD is equal to PF. If this case is satisfied, it is called as parabola. It is called parabola. But in ellipse and hyperbola, it will be different. The eccentricity is less than 1 for ellipse, and for hyperbola, it is greater than 1. So for parabola, now I will discuss what are the different types of equations we will get. And the first equation, I will write here 4 different parabolas. The first parabola is this one. I already explained to you, that is this one. Y square is equal to 4ax parabola. And the second parabola is, one second. The second parabola is this one. That is the reverse of the first parabola. This one. And the third parabola. The third parabola is this one. And the fourth parabola is this one. If you observe carefully, what is the main difference here? This is y square equal to 4ax, and this is y square is equal to minus 4ax, and this one is x square equal to 4ay, and this one is x square is equal to minus 4ay. For this parabola, I will discuss here only. The line, this line, it is called directrix. Here this line is called directrix. Here I already explained what is the eccentricity. Here the fixed line, I think this is not the actual point. I will drop here. This is not the actual point which I want to discuss. The actual point will be this one. That is, here if I draw one line, this is the directrix, which is a fixed line. This is a fixed line, and this distance I am discussing, not this distance, because this is a distance of a point from y-axis. I am not discussing that one. I am discussing the directrix distance, and the distance from a fixed line, which is called as directrix, to the fixed point is always is equal to 1. That is, both the distances are equal. If I trace the locus, the shape will be this one, the parabola. And in this case, it is the directrix of this equation, and in this case the directrix is this one, and in this case the directrix is this one. And if you observe carefully, what is the focus then? The focus here is a comma 0, and the focus here is minus a comma 0. F is called focus, which is a fixed point, and here the focus is 0 comma a, and here the focus is 0 comma minus a. Yes. And the directrix equation, very important. What is the directrix equation here? It is the a distance equal, this distance and distance is equal, and the directrix equation equals to x equal to minus a. So x equal to minus a is the directrix equation of y square equal to 4ax. And what is the directrix equation of y square equal to minus 4ax? It will be x equal to a. And what is the directrix equation of x square equal to 4ay? It is y is equal to minus a, and in this equation it is y is equal to plus a. So like this, the directrix equation, what is the focus, we have to remember. This is a very important. And if you observe very carefully, in the parabola we will discuss some terms that is called latus rectum. What is latus rectum? Latus rectum is nothing but the point, that is the line which is passing through the focus and it is perpendicular to the axis. This is called axis. If the line is passing through the focus and it is perpendicular to the axis, that line is called latus rectum, and this length is equal to 2a. The length of the latus rectum is equal to 2a upper and 2a this down, because when you substitute the a point here, you will get 2a as these points. So I can write the coordinates of these points. What is the coordinate? The coordinate is a comma 2a, and this coordinate is a comma minus 2a. And if I add the distance, this is the y-axis length, so it will be 2a plus 2a. It will be 4a. So the entire length will be 4a, entire length of latus rectum. And the point at which it is cutting the x-axis, it is called vertex. It is called vertex. So you can visualize this. What is the latus rectum of this type, y square equal to minus 4ax? It will be minus a comma 2a, and it will be minus a comma minus 2a. So and the vertex is 0 comma 0 only. So this is the different types of parabola which I want to discuss. And now I will discuss the parametric coordinates. Parametric coordinates. What are the parametric coordinates? In the case of circle, what I discussed, the parametric coordinates are a cos theta, comma a sin theta in case of circle. But in case of parabola, there are 4 types of equations, that is y square equal to 4ax, and y square is equal to minus 4ax, and the next equation is x square equal to 4ay, and next is equation is x square equal to minus 4ay. If you observe these 4 different equations, there are different parametric coordinates. That is how we can find the parametric coordinates. Parametric coordinates is nothing but it should satisfy the every point on the parabola. That type of points we have to get. So here if I observe, this is 4a. If I substitute x value as at square, it will become a perfect square. Then I can find the value of y. So I am substituting at square in the place of x. What I get? I get 4a square t square. So 4a square t square, I can write 2at whole square. So power will get cancelled. So y value will be 2at. So this is the parametric coordinate of parabola y square equal to 4ax. But it will change here. Here what x I have to substitute in order to make this perfect square, and the negative should be positive. So I will substitute minus at square here. Minus at square comma 2at will be the parametric coordinate. In the case of this, the y value should be substituted at square, so that the x value should be we will get 2at. Same here also, the y value should be substituted minus at square in order to make the positive and in order to make the perfect square, and the x value we will get 2at. So these 4 are the parametric coordinates for different types of parabola. 4 types of parabola have 4 types of different types of parametric coordinates. Suppose if in the parabola chapter, the only important equation is y square equal to 4ax. So everything what we discuss is depend on this equation only. But I will discuss the tangent equations and normal equations for different parabolas also, but the main focus should be y square equal to 4ax. So suppose y square equal to 4ax, what are the parametric coordinates I said? Parametric coordinates is equal to at square comma 2at. Yes, but if the equation of the parabola is not of this type, if the vertex is not at 0, 0, if the vertex is h comma k, if the vertex is at h comma k, what you can do? We can write the equation as y minus h whole square, that is y minus k whole square is equal to 4a into x minus h. Yes, for this type, what is the change in parametric coordinates? The change in parametric coordinates is just we have to add the vertex to the parametric coordinates of the above. That is, here the vertex is h comma k. So just add the values, that is h plus 80 square comma k plus 280, or the new parametric coordinates of the type y minus k whole square is equal to 4a into x minus h. So these are the parametric coordinates you have to understand. And one more thing, this t is called parameter here. The t can be variable. Suppose again for y square equal to 4ax, now I am defining the slope of chord. Slope of chord. I forgot to say that this is, if this is a parabola, the chord is just joining 2 points. If it is passing through focus, it is called focal chord. And if it is perpendicular, there are 3 types of chords. The first one is chord, the second one is focal chord, and the third one is chord, focal chord, and latus rectum. What is latus rectum? It should pass through focus and it should perpendicular to axis. But focal chord is just passing through focus. That is, if this is a focus, just it has to pass through the focus. It will call as focal chord. And chord is, it is just passing through 2 points. It is called chord. But what is latus rectum? Latus rectum should pass through the focus and it should perpendicular to the axis. So I am calculating now slope of chord, any chord. Suppose I am drawing again the graph of y square equal to 4ax curve. Suppose at t1 there is a point, at t2 there is a point. In order to find this, the slope of this line, which is called as chord, what I have to do? What is t1 values? That is at1 square comma 2at1. Yes. And what is t2? at2 square comma 2at2. at square comma 2at2. Now if you observe carefully, if I want to calculate the slope between 2 lines, that is 2 points, what I have to do? I have to subtract the y indices and x indices. So y indices are called ordinates. I have to subtract the ordinates and divide the ordinates with the abscissa difference. So it will be slope of chord is equal to 2at2 minus 2at1 divided by at2 square minus at1 square. So if you observe carefully, I can take common 2a and t2 minus t1 will be same, and again here I can take common 2a and t2 square minus t1 square I can write as t1 plus t2 into t2 minus t1, and here I can cancel these two and a will be cancelled. So from this what we got slope of chord. Slope of chord is equal to 2 by t1 plus t2. This is the important result. I will star mark the results. You have to remember those results. And one more thing. The one more result is, suppose this is a parabola. Suppose this is a parameter t1 and this is a parameter t2. Suppose if it is making the right angle at the origin, the joining of these 2 points, if it is making the right angle at the origin, what is the relation between t1 and t2? And the origin is 0, 0. What I can do now? If it is making the right angle at the vertex, what I can do? I can simplify the relation. It is 0, 0 and it is at1 square comma 2at1 and it is at2 square comma 2at2. So if you observe carefully, I can find the slope of 0, 0 and at1 square comma 2at1. What is the slope? The slope is t1 comma at1 square, and I can cancel and I will get 2 by t1. 2 by t1 from this side, and from this side I will get 2 by t2. What is the main important thing? The multiplication of these two slopes should be negative. That is 2 by t1 multiplication with the 2 by t2 should be -1 because these are perpendicular. So what is the relation we got here? We got 4 divided by t1 t2 is equal to -1. So t1 t2 is equal to -4. This is a relation we got. This is also another important relation. That is how when to use this relation. If in the question, if it is demanding that the two parameters on the parabola, they are making the right angle at the vertex, then find the points. They will give one relation, you have to find the points. Then you have to use this parameter, that is T1, T2. Suppose if they given T2 coordinates, in order to find the T1 coordinates, what you have to do? We have to find T1 is equal to minus 4 by T2. Then you can find the parameter T1 and just supply in the that is we can say substitute in the a T1 square comma a T 2a T1. T1 should be substituted and a is already known, so you can find the coordinate. Like this you have to do. And I already discussed in the first I will discuss the slope of chord. Here I discuss the slope of chord, simple chord. What if it is the focal chord? Suppose if it is passing through the focus. Suppose the chord is focal chord. Suppose the chord is focal chord, then what is the relation? This is a parabola and this is the focus, it is passing through a, 0. Yes, the point is a T1 square comma 2a T1 and the point here is a T2 square comma 2a T2. Yes, now the relation is, could be the relation could be T1 T2 is equal to minus 1. Very important, that is T1 T2 should be equal to minus 1. This is an important relation you have to remember again. That is when it is passing through the focus a, 0, the product of T1 and T2 will be is equal to minus 1. Very important. Because how we can prove this one? The slope of this line should be is equal to this line, yes. So what is the slope of this line? It will be 2a T1 divided by a T1 square minus a. This is the slope. And what is this slope? This slope is a 2a T1 T2, here it is T2, sorry, 2a T2 divided by a T2 square minus a. If I find the value, what I will get? I will get 2a T2 divided by a into T2 square minus 1. A will get cancelled. 2t2 divided by t2 square minus 1. Here you will get 2t1 divided by t1 square minus 1. So these slopes are equal. Yes. So 2t1 divided by t1 square minus 1 is equal to 2t2 divided by t2 square minus 1. So 2 will get cancelled. And if I multiply, what I will get? I will get t1 t2 square minus t1 is equal to t2 t1 square minus t2. So from both, what I can take common? From this, if I take common and solve, I should get t1 t2 is equal to minus 1. Suppose if you think this is a focal chord, 1 second. So let it be, I will leave here because the slope of the chord. Suppose that is we are not getting the actual relation. Now we will break it down in another way. I already found the slope of the chord, that is 2 by t1 plus t2. This result you already know. This is the chord slope. Yes. Now it becomes a focal slope. So when with the help of t1 parameter, if I write the relation a t1 square comma 2a t1, if I find the line, it should pass through focus. So I will write that line 2y minus 2a t1 is equal to slope, that is 2 by t1 t2 into x minus a t1 square. Here it should satisfy a comma 0. So when I substitute here, it will be minus 2a t1 is equal to 2 divided by t1 plus t2 into a minus a t1 square. Now when you observe, 2 will be gets cancelled with 2. And here if I take common here, a will gets cancelled. So what is left? Minus t1 is equal to 1 minus t1 square divided by t1 plus t2. Yes. So when I multiply it, I will get minus t1 square plus minus t1 t2 is equal to 1 minus t1 square. So 1 minus t1 square, 1 minus t1 square will get cancelled. Minus t1 t2 is equal to 1. So t1 t2 is equal to minus 1. So like this you have to solve. The slope which we find in the initial, that is t2 divided by t1 plus t2, is the slope of the chord. That slope of the chord can be again used to find the relation between the t1 and t2, which are now become the parameters of the focal chord. Because this is a chord. Now we discuss the relation of focal chord. I discussed the three relations. What are those? The slope of the chord is 2 divided by t1 plus t2, and the second relation is when the parabola is there and there are two parameters which are making the right angle at the vertex, the relation will be t1 t2 is equal to minus 4. This is another relation, and now the main relation is focal chord relation, that is t1 and t2 is equal to minus 1. So you will get confused, so you have to understand where you have to use. Now what is the length? What is the length of focal chord? The length of the focal chord we have to find. That is, we already know the parameters, that is at1 square comma 2at1. Another parameter also known, that is at2 square comma 2at2. And the focal length is also known, that is a comma 0. If I find the distance between these two, it is a length. So how I can solve it as, I can solve the length as a into t plus 1 by t whole square. In terms of parameter, suppose t is a parameter, if I want to find the length, it will be like this, that is a into t plus 1 by t whole square. This is the length of the focal chord. And in terms of angle, this is the length of, in terms of parameter. That is, it is in terms of parameter. Yes. Now I want to discuss the length in terms of angle. So what is the length of the focal chord in terms of angle? The length of the focal chord in terms of angle is 4a alpha square, that is 4a cosecant square alpha. This is a relation, that is 4a cosecant square alpha is the length of the focal chord in terms of angle. Now semi-lattice rectum, semi-lattice rectum, that is semi-lattice rectum, if you find, suppose this is a thing, suppose these are the two lengths, that is L1 and this is the length is L2, and it is a comma 0 and the parameter is t1 and t2. If you observe very carefully, it is the harmonic mean of the length L1 and L2, that is harmonic mean of L1 L2, that is a relation of L1 and L2 is equal to LR by 2. This is a relation. What is the harmonic mean of L1 and L2? It will be 2L1 L2 divided by L1 plus L2 is equal to LR by 2. What is LR by 2? It is 4A by 2. It will be 2A. So the relation of L1 L2 with the 2A will be like this. That is, the lengths can be, suppose in the question they will ask the semi-lattice rectum, the length is L1, they will give some value 5 and you have to find the L2 value, and the equation is given as y square equal to 4ax, and a will be 1, that is 4 into 1 into x, let it be. Here a is equal to 1 and L1 is equal to 5. We can find L2 by using this relation, that is L2 is equal to, we can use here this relation, that is 2L1 L2 divided by L1 plus L2 is equal to 2A. Just substitute the values of L1 and A in the place of that one and find the L2. Yes. Now again the same concept which we discussed in the circle, that is position of point with respect to parabola. What is the position of point with respect to parabola? We have to find this. So I already said we have to draw the parabola and we have to check the position of point can be inside on the parabola or it can be here, that is outside. Now we know the equation y square equal to 4ax, and y square minus 4ax is called as a notation, and this notation I already discussed, that is yes. So now I have to substitute the given point. Suppose the point is x1 comma y1. I have to substitute, that is s1, that is y1 square minus 4ax1. If I substitute and find the answer, yes, this value depends on this value, it will decide the position whether it is inside on the parabola or outside. If this value is greater than 0 or less than 0 is equal to 0, equal to 0 is nothing but on the parabola. Equal to will be on the parabola, less than will be less than 0 will be inside the parabola, and greater than 0 will be outside the parabola. This is the main important results. Greater than 0 will be the outside the parabola, less than 0 will be the inside the parabola, and equal to 0 will be the equal to 0 will be the satisfying point of the parabola. So you have to understand how to evaluate. The point is given. After the point is given, you have to visualize the parabola and you have to substitute the value. After substituting the value, whether it is 0, greater than 0, less than 0, depending on those conditions, we can say whether the point is present inside the parabola, or on the parabola, or outside the parabola. Now this is a position of point with respect to parabola. What is the position of the line? What is the position of the line with respect to parabola? This is a main important thing. What is the position of the line? Now I am going to discuss the line. So if you observe carefully, this is a parabola. How many types of, that is how many cases will be possible? That is, the line can be like this, the line can be like this, the line can be like this. What are the three different lines here we have discussing here? This is a non-intersecting line, non-intersecting, because it is not intersecting the given parabola. And this is the tangent, because it is touching the parabola, but this line is the intersecting line. So there are three different possibilities: intersecting line, here it is a non-intersecting line, it is tangent line. Very important. So how we can decide whether the given line is tangent or not? There we will get one condition, that is the given parabola is y square equal to 4ax, and the line, let it be y equal to mx plus c. In order to say y equal to mx plus c is the tangent to y square equal to 4ax parabola, what is the condition? The condition is a minus mc. A minus mc greater than 0, a minus mc less than 0, a minus mc is equal to 0. If a minus mc is greater than 0, it is intersecting. So when parabola is given and the line is given, you have to find the value of a and you have to calculate the value of m. After calculating, just here m also calculate and c also calculate, just find the relation, that is a minus mc. A minus mc, if it is greater than 0, then it is intersecting. If it is less than 0, it is non-intersecting. And if it is equal to 0, it is tangent. Yes, how I got this relation? I got this relation simply substituting the value of y in this value and then deriving the condition. When I derived the condition, I got a minus mc as a result. This a minus mc should be greater than 0 in order to intersect. That is the discriminant, you can say. In order to intersect, that is, in order to get the result as intersecting line, it should satisfy this relation, that is a minus mc greater than 0. And if a minus mc is equal to 0, then it is a tangent. And if a minus mc less than 0, then it becomes non-intersecting, because here you do not get any intersecting points. So the given parabola and the line are not intersecting when the condition is a minus mc less than 0. This is the important cases. And if the tangent case, if you observe very carefully, a minus mc equal to 0 they are saying. And what is a equal to mc? That is a minus mc equal to 0. What is a? A is equal to mc. I want to see now. C is equal to a by m. This is the condition of C. Yes. So I already said y is equal to mx plus c is a line which is tangent. So what is a tangent in slope form? Now only the answer is revealed. That is y is equal to mx plus what is c value? C value is a by m. So y equal to mx plus a by m is the tangent equation in slope format. Yes. Now I discuss the that one, and what is the length? This is not needed. And now I will discuss the equations. Now comes the important part, that is equation of tangent. What is the equation of tangent? What is the equation of tangent? First of all, I will discuss the equation of tangents. There are so many ways in order to discuss. First of all, that is point form. In point format, what is the equation of tangents? There are so many parabolas. That is y square equal to 4x, there is a parabola. Y square equal to minus 4ax, there is a parabola. And you already know x square is equal to 4ay is a parabola, and x square is equal to minus 4ay is another parabola. If you observe carefully, what is the point format it is saying? I already explained the circle equation. Suppose the circle equation is x square plus y square equal to a square. What I have to do? I have to transform this equation in order to get the equation of tangent. What I said? x square is transformed as x(x1), and y square is transformed as y by 1, and x should be transformed as x plus x1 by 2, x plus x1 by 2, and y should be transformed as y plus y1 by 2. Yes, yes, it is important. Same thing will be applied here. What is a y square equal to 4x transformed value? That is t, which is called as tangent. Tangent equation is y by 1 minus 2a into x plus x1 is equal to 0 is a tangent equation for y square equal to 4ax at the point y1 and x1, that is x1 comma y1, and for this equation the tangent will be y by 1 plus 2a into x plus x1. You have to remember like this only. There is no need of memorization, just understand. Suppose the equation given is y square equal to 4x. Okay, y square equal to y by 1. And if it is comes to the left side, it will be minus 2a into x plus x1. Yes, and for this, t is equal to x(x1) minus 2a into y plus y1 is equal to 0. And for this one, it will be t is equal to x(x1) plus 2a into y plus y1 is equal to 0. There is a slight changes in the equation. In the place of y, now comes the x. That's it. The remaining everything will be same. This is a point format. Everything is discussed. And what is the point of contact of the tangent to the parabola? It will be x1 comma y1. You have to understand what is the point of contact, x1 comma y1, because we have to write the point of contact in the equation itself in order to find the solution. So that is the reason the point form is very easy. And the second is parametric format. Parametric format. In the parametric format, there are so many things you have to understand. I will discuss everything. 1 second, guys. There is a trouble. Yes, now it is okay. There are 4 formats. What is the first one? That is y square is equal to 4ax. Second one, y square is equal to minus 4ax. I will explain in every parabola tangent equation. So you have to understand very carefully. And x square is equal to minus 4ay. If you observe very carefully, what are the parametric coordinates for this? It is 80 square comma 280, I said. And what are the parametric coordinates? It will be minus 80 square comma 280. And what are the parametric coordinates? It is 280 comma 80 square. And for this it is 280 comma minus 80 square. Yes. And what are the tangent equations I discussed here? The tangent equation is y by 1 minus 2a into x plus x1 is equal to 0. And what is the equation here? I think it is y by 1 plus 2a into x plus x1. Yes. And what is the equation here? x(x1) minus 2a into y plus y1. And here it is x(x1) plus 2a into y plus y1 is equal to 0. These are the tangent equations in point format. But why I written here in the parametric format? Because there is this only change in this, that is x1 comma x, that is x1 comma y1 is replaced now with the parametric coordinates of individual lines, that is individual parabolas. Just replace with this one. That is, suppose in order to find the parametric format equation of y square equal to 4ax, just substitute x1 as 80 square, y1 as 280. What you will get? You will get y into 280 minus 2a into x plus 80 square is equal to 0. And when I solve this, I will get 280y minus 2ax, 2ax, and if I observe carefully, 2a into x plus I think it is 80 square. If you observe carefully, 2a will get cancelled. What I will get? I will get ty is equal to x plus 80 square I will get. So ty equal to x plus 80 square is the answer for this. Same way you have to substitute here. What you will get? In the place of y1 you have to substitute 280. In the place of x1 you have to substitute minus 280. So what you will get? You will get ty is equal to, I think when I substitute here, I think it is I think here it is a 2a will get cancelled again. The x will be negative. Yes, the x will be negative. It will be minus x plus 80 square. Simple change. Ty is equal to minus x plus 80 square. In the same way, what is the third equation you will get? You will get Tx is equal to y plus at square. Yes? Yes or not? I will verify. Because we cannot write blindly, we have to check once. Because after checking, you can write directly. Substitute here. That is x into 2at minus 2a into y plus at square. The 2a will get cancelled and you will get, I think, x t is equal to y plus 8 square. Yes, what we written is 100% correct. That is xt, that, or you can write as tx is equal to y plus 8 square. So now it is very obvious. What is the fourth parabola equation of tangent in the parametric form? That is tx is equal to minus y plus 8 square. If you observe very carefully, when it is starting y square equal to 4x, when it is y, you will get y here. When it is x, you will get x here. Yes. So when it is y square equal to 4x, it will be ty equal to x plus 8 square. When it is y square minus 4x, you will get ty equal to minus x plus 8 square. And when it is x square equal to 4ay, you will get tx is equal to y plus 8 square. And when it is y square equal, that is x square equal to minus 4ay, you will get tx is equal to minus y plus 8 square. That's it. Just slight changes. The change is here. The change is here. When it is changes to the next corresponding parabola, it will change the sign. And when complete parabola is changing, you will get the change of variables. That is here, y will be replaced with x and x will be replaced with y. This is a equation of tangent in parametric form. Equation of tangents in parametric form. And slope form. I think I will explain the slope forms 1 second. But before that, I will explain the properties. 1 second. Before that one, I will explain the properties of tangents. Properties of tangents. Simply listen, guys. The portion of the tangent to the parabola cut off between the directrix and direction of the curve subtends a right angle at the focus. Very important. Suppose this is the parabola and this is a directrix. Suppose if you observe, this is a tangent. This is the point. This is the point. These two will make the focus right angle here. This is the thing. That is the portion. Suppose this is a portion. If I extend to the focus, the right angle will be formed. That is a one property. At the focus, the right angle will be formed. This is the directrix and this is the portion of tangent. Yes. And the next property will be suppose there is a tangent, there is a parabola like this and there is a directrix here. Again the part here from the focus, if I join here and if I write the perpendicular, it will intersect, it will fall on the perpendicular. It is very important. This is another property. Now I think I have to write here, that is tangents in slope format. Yes, tangents in slope format I have to write. For y square is equal to 4ax, y is equal to mx plus c. When I solved, I got the condition y equal to mx plus a by m. Yes, I got the condition y equal to mx plus a by m. So here the c is changing. That equal to yx, y equal to mx plus a by m. And I think I didn't write in the notes, I think. 1 second, I will verify. Suppose now I am writing the slope formats in order to make you understand. I can give some glimpse between the relation, that is the relation between parametric value t and m. So if I take the first parabola, that is y square is equal to 4ax, what I got, if I differentiate this, 2y y dash is equal to 4a. What is y dash? It is 4a by 2y. What I got, 2a by y. If I substitute the y value, what is at1 square comma 2at1? When I substitute here, what I got? I got 2a divided by 2at1. What I got? M slope will be equal to 1 by t1. Yes. So what is the relation here? M is equal to 1 by t1. So if I want to write m in the terms of m, what I have to substitute? T is equal to 1 by m, I have to substitute. What is the equation of this one in the terms of parameter? Parameter is equal to ty equal to x plus at square. Yes. So substitute t is equal to 1 by m here. That is y by m is equal to x plus a by m square. When I solve this, what I will get? I will get y m is equal to x m square plus a. Yes. So I think when I divide with m, what I will get? I will get mx plus a by m. Yes. So now comes the important thing here. We have to understand the logic. That is, y square is equal to 4ax is a parabola. Second parabola is y square equal to minus 4ax. And the third parabola is x square is equal to 4ay. And the fourth parabola is x square equal to minus 4ay. Yes. For this thing, you have to understand the relation between the parameter t and m. For this, the relation is m is equal to 1 by t. For this, the m is equal to minus 1 by t. For this, m is equal to t, and for this, m is equal to minus t. That's it. How I got these relations? Just differentiate. Suppose if I want to find this relation, I will differentiate this. 2x is equal to minus 4a y dash. So what is y dash? It will be minus 2x by 4y. So what I got? I got x minus x by 2a. Yes. So what is x here? X is 2at divided by 2a. 2a will get cancelled, minus is there, so it will be minus t. Relation between t and m in terms of tangent, if it is. In terms of slope, this is changed completely. In terms of slope, it will be opposite. That is, t 1 by t you have to multiply what in order to get minus 1? That is minus t. Here you will get t. Here you will get minus 1 by t. Here you will get 1 by t. So these are the relations for normal. So simply when the slope format and parametric format are written in the tangents, just replace those things with these things. That is the relation between the m and t. Yes. And one more thing. In the slope, so that is a point format and parametric format, you know the point of contact of the parabola with the tangent. That is, in the point format it is x1 comma y1, and in the parametric format it is at square comma 2at. If it is the y square equal to 4x parabola, if other parabolas you already know. Now I want to find the point of contact for parabola in terms of slope. How I can get? Simply take this one, that is a parametric coordinates, that is at square comma 2at. Another parabola, that is this is y square equal to 4ax, and this is y square equal to minus 4ax, and this is x square equal to 4ay, and this is x square equal to minus 4ay. If you observe very carefully, this is the parametric coordinates, and this for this one it is minus 8 square comma 280, and for this one it is 280 comma 8 square, and for this one it is 280 comma minus 8 square. Yes, understand? Now for this one, what is the relation of t with respect to m? Yes, t is equal to 1 by m here. Here t is equal to minus 1 by m. Yes, here t is equal to m, and here t is equal to minus m. Yes, simply substitute here. What you will get? A by m square comma 2a by m, point of contact. Here you will get I think here you will get a by m square comma minus 2a by m. Yes, because t we have to substitute, and here I think here it is 2am comma am square, and here you will get, I think here you will get minus 2am comma minus am square. That's it. These are all the point of contacts in terms of slope. Now you have found out the relation, how you can evaluate. This is the main important thing I want to say. That is the point format I have found out, the equation, the parametric format I have found out, but the slope format is different from those because the point is not mentioned. We have to find the point of contact. For those, the result is this one. These are the point of contacts for 4 different parabolas. The main important thing is, up to now I didn't mug up a single formula in parabola. That is, I didn't mug up any equations. The formula I have mug up, that is suppose what is the length of the focal chord? The length of the focal chord in terms of parameters 4 plus t plus 1 by t, that is a into 1 plus t plus 1 by t whole square. This thing I have mug up, and in terms of angle, what I said, 4a cosecant square alpha, this thing I have mug up, but I didn't mug up a single equation. What I mug up? I mug up the process, how to evaluate, how to derive, if I forgot, because these many equations I didn't have the capacity to remember. But some people will remember. It will be very simple for you, but simple for them, but for me it is very difficult to remember. Then what I thought, should I remember the formula? That is, should I remember the equation? Should I remember the process? Then I realized that remembering the process to evaluate the point of contact, the equation in the slope format, parametric format, and you can think of point format, parametric format. These things are very helpful. That is, the procedure is very helpful than the remembering. If you remember, it will be second. It will be the 1 second just to apply. But in order to recall, it will take 30 seconds. But it is worth it. You cannot make any mistakes here, but there is a high chances you will make mistakes here, because in JMS you are remembering up so many, nearly thousands of formulas in math, physics, chemistry. So you cannot do this type of mistakes. Remember some formulas, some procedures also you should remember. Now comes the important, that is normal. What is normal equation? I already discussed. Suppose let it be the point. Suppose if I discuss y square is equal to 4ax, for this I here also there will be 3 formats, I think. That is a point format, parametric format, and slope format. Suppose now I am discussing the point format. What I will get? Point format. The point here we are discussing is 80 square comma 280. Yes, I differentiate this one in order to get the slope of normal. It is reverse of the slope of tangent. So if you observe very carefully, what is the thing here? The thing is 2y dash is equal to 4a, y dash is equal to 4a by 2y. 2 will get cancelled, that is equal to 2a by y. And when I substitute y as a 280, I will get y dash is equal to 1 by t. But this is a slope of tangent. So the slope of normal becomes 1 minus t, because when you multiply these two you will get minus 1 as a result. So the slope of normal is minus t now. Yes. And what is the point format's equations? Point format's equation, suppose if I recall, y square equal to 4ax, what is the equation? The equation is y by 1 minus 2a into x plus x1 is this one equation. But the important thing is, at the point, how I can write the thing, that is now we have to understand. Very important thing you have to understand, that is how I can write the normal equation in terms of this one. That is how I can find the normal equation. Suppose for this I will help you. That is, suppose I am evaluating at point x1 comma y1. Yes. Suppose if I take this one as x1 comma y1, and this parabola is y square is equal to 4ax. At this point I want to make the normal. Yes. And you already know the normal is the perpendicular of the tangent. That is when it is intersecting at a 90 degree, it is called as the normal. Yes. Y square equal to 4ax is a parabola, and you already know x1 comma y1 is a point on the parabola where you have to draw the normal. So what we can do? We can use this x1 y1 equation, that is y minus y1 is equal to slope of normal into x minus x1. And when the slope of normal is found, we can apply here. What is slope of normal? By using this equation, what I can do, y1 is equal to 4ax. y1 is equal to 4a by y. That is 2y here, I think. Yes, 2 will get cancelled. 2a by y1 when I substitute the y1 point. So 2a by y1 is the slope of the tangent, but I want normal slope, that is y1 by 2a, reverse of this and negative sign. When I multiply these two, I will get -1. So this is the right. So this thing I have to substitute here. That is y1 minus y1 divided by 2a is the answer. So this is a normal equation in terms of that is in the point form. Now comes the parametric form. Parametric form. How the equation changes? In the parametric form, you have to understand. In the parametric form, we have to understand. We will use the point as at square comma 280 in the case of this one. That is what thing? In the case of y square equal to 4ax. Yes. Now I already said this is the normal equation in the point form. So the point x1 y1, I will substitute now these points at square comma 280. Now the equation changes. Y minus 280 is equal to 280 divided by 2a into x minus 80 square. What I will get now? I will get this one will get cancelled. Y minus 280 is equal to minus tx plus 80 square. Now, what is the value of y? Y equal to minus tx plus 280 plus 80 square. 80 square or 80 cube? It is t into t square. It will be t cube. So, this is the answer. That is y equal to minus tx plus 280 plus 80 cube is a normal equation. This is a normal equation for parabola in parametric form. Suppose I want to write for the parabola x square is equal to 4ay. For this parabola, if I want to write, what is the main change here? The main change will be the slope. Y minus y1 is equal to slope. Yes, slope into x minus x1 is an equation. How we define the slope? The slope here is very important. The relation which I already discussed. What is the relation I already discussed? I discussed the relation as here, the box where I written the tabular form. I think this is not, 1 second. Where I discuss the relations? Sorry, 1 second. Here, the relations of slopes in the normal form. This is a tangent form, it is okay, but here it will be changed. Now I am discussing x square equal 4y. So it is minus 1 by t is the slope of normal. So simply substitute minus 1 by t. Minus 1 by t is a slope. And y1 x1 values are what you get? You got 280 comma 80 square. Yes. So y minus 80 square is equal to minus 1 by t into x minus 280. Now yt minus 80 cube is equal to minus x plus 280. What you will get? You will get equation as x is equal to minus yt plus 280 plus 80 cube. If you observe this equation and this equation, what is the main difference you have found? You have found here in the place of x, you got x, that is y in the place of x, and here minus tx, you got here ty minus ty. So there is only the shift of the variables, but the equation didn't change. So now, if I didn't remember equation, I can directly write, that is y is equal to minus tx plus 280 plus 80 cube is the y square equal to 4x normal equation, and y is equal to tx minus 280 minus 80 cube. I think it is the correct only. Let's verify one time, that is y minus y1 is equal to, what is the slope? If it is I think it is minus t, it will be plus t. So it will be t into x minus x1. If I substitute the values, y minus what are the points of y square equal to minus 4x? Y square equal to minus 4x. What are the parametric coordinates? The parametric coordinates are, I think it is minus 80 square comma 280. Yes, simply substitute this one. 280 equal to t into x plus 80 square. What you will get? Y minus 280 is equal to tx plus 80 cube. So it will be y is equal to tx plus 280 plus 80 cube. Yes, simple thing. That is, for y square equal to 4x, the equation will be minus tx plus 280 plus 80 cube. For y square equal to minus 4ay, that is minus 4ax, you will get y equal to plus tx. So for this, I can write the equations for x square equal to 4ay. What is the equation you will get? You will get x is equal to minus ty plus 280 plus 80 cube. One result. Another result you will get. What you will get? You will get x is equal to plus ty plus 280 plus 80 cube. This is a normal equation for x square is equal to minus 4ay. That's it. We have completed the slope form, that is a point form, and the parametric form. Now comes the normal form. That is a slope form. Slope form, what I said, simply substitute the parameter by slope. That is, what is the relation between these two? That is the slope of the normal and t. That is, m is equal to minus t, m is equal to minus 1 by t. I think it is wrong. I think it is wait a second, I will verify. Here minus t, sorry, it is minus t. Here it is minus t and t. Minus t and t, and for another parabola it is m is equal to minus 1 by t, and for another parabola it will be 1 by t. Yes, simply use these relations. So what is t is equal to? T is equal to minus m here, t is equal to m here, t is equal to minus 1 by m here, t is equal to 1 by m. Simply substitute t value of the equations, this equation. Suppose y square equal to 4ax. For this equation, the parametric form will be what I will get? I will get y is equal to tx minus tx plus 280 plus 80 cube. I will get, yes. Here substitute t as minus m. Y is equal to mx plus minus 2am minus am cube. That's it. This is the answer. Substitute everything. For everything, you have to substitute and find the answer. This is called as the equation of normal of slope format. Suppose now the slope and these things are completed. Suppose this is a parabola. Suppose there is a point h comma k. How many normals can be drawn? Maximum of 3 normals can be drawn. 3 normals can be drawn from a point. So how I said? Because in the equation, if you observe here, there is a cube, that is a cube root. So it will get 3 values of m. So 3 values of m is nothing but 3 normals. So 3 normals can be drawn from a fixed point given. And there is another important relation, that is point of intersection of normal and t1 and t2 at t1 and t2. Suppose at t1 I have drawn one normal, at t2 I have drawn one normal. In order to find the point of intersection of the normals at t1 and t2, the relation is 2a plus a into t1 square plus t1 t2 plus t2 square is a one relation. Yes, and another point is a t1 t2 into t1 plus t2. This is another relation. That is 2a plus a into t1 square plus t1 t2 plus t2 square, comma a t1 t2 into t1 plus t2 is another point. This is the point of intersection of normals at t1 and t2. Now here also you will get the director circle concept. Director circle. What is the mean by director circle? I already said it is the point of it is a circle. It is a type of circle. Suppose for this I draw two tangents, and the point of intersection will give a right angle, and with the help of this, if I draw the circle, this circle is called director circle, because it is a point of intersection of perpendicular tangents, and with that point, if I draw the circle, it will be director circle. That's it. And here the common results will be again same. That is what is a chord equation? Suppose this is a parabola. There is a point. when two tangents are drawn, you will find a chord. What is the chord equation? T is equal to 0. This is one equation. And chord with given midpoint. Chord with given midpoint. Given midpoint. What is chord with given midpoint? The chord with the given midpoint is like this. Suppose this is a thing, and the one midpoint is given. Suppose it can be of x1 comma y1. Now the equation changes to t is equal to s1. I already said what is t? T is equal to y square minus 4ax is equal to 0. And what is s? Sorry. It is s. It is a t. It is y1 minus 2a into x plus x1. The transformed equation. This is t and this is s. 1 second, I will drop because you will confuse again. This is s. This is t. And what is t is equal to s1? T is equal to s1 is nothing but this one. That is y1 minus 2a into x plus x1. x1 is equal to, what is s1? The substituted point, that is y1 square minus 4a x1. s1 is equal to y1 square minus 4a x1 is equal to 0. This is the result. Not equal to 0, we cannot write equal to 0 because it is very ugly because cannot be 0 because it having some value. So this is the t equal to s1. And the next thing is chord we have discussed, the t equal to 0, chord with the given midpoint we have discussed, that is t equal to s1. Now pair of tangents. Pair of tangents. What is the pair of tangents? The pair of tangents is, suppose we have taken the parabola and we have from the external point x comma y, we have drawn the two things. Suppose you can take the point as not x comma y, we can take x1 comma y1 because x comma y we have used in the equation. Suppose if you see any equation, there present only y and x, that is x and y only present. So if you again use x and y, there is no change in the equation. So I have taken the point as x1 comma y1, and if I from this point if I draw two tangents and I want to write the equation for this pair of tangents, that is pair of tangents equation. Pair of tangents equation, if I want to write, then the equation will be s into s1 is equal to t square. I already discussed what is s. S is this one. What is s1? S1 is this one. And what is t? T is this one. The square of this. That is square. And sorry. 1 second. Not. 1 second. I think s into s1. I think s into s1 is equal to t square. This is, you already know, that is y square minus 4x. And into s1, you already know the into s1 will be this one. The point which we substitute a y1 square minus 4ax1. And what is t here? T is a transformed equation, is equal to t square. T is this one. This transformed equation. Very, very important. That is s into s1 is equal to t square. S into s1 is equal to t square is the answer. S into s1 is s into s1 is equal to t square is the answer. And one more thing, it is very important, that is the reflection property. I think it is very important to understand what is the reflection property. 1 second, guys. Hello. Sorry, guys. There is a slight disturbance. Now I will explain the reflection property. The reflection property says that suppose this is a parabola and the ray is coming like this and will strike this one and it will pass the focus and it will pass through the focus. This is the reflection property. And at the point, if I draw the normal and tangent, this is the normal and this is a tangent. If you observe very carefully, this is the normal and tangent. This tangent will intersect here, that is minus 80 square comma 0 at point, and at this thing it will intersect at 2a plus 80 square comma 0. At these points it will intersect. What is just a comma 0? If you observe very carefully here, the points, yes, here it is t. If you observe, it is t and it is n, I think. Yes, it is n. And the point p, at what point it is touching the surface? It is 80 square comma 280. Yes. So if you observe carefully, there is here we got the one important relation, that this one, these three, that is this one and this one is equal. That is the distance. St, this distance st is equal to Sn, this distance Sn, and this is equal to Sp. Very important. That is the point at which it is striking is equal to, that is the distance of focus. Focus from the point of touching is equal to the distance of focus and the t, that is the tangent intersection with x-axis, and the distance of S, the distance from S and the normal touching, it will gives the result. That is this distance, and this distance 3 are equal. That is Sn is equal to Sp is equal to St. That is a normal point and tangent. Thus, distance from focus will be equal. This is a reflection property of parabola. This is a very important thing, and that's it, guys. I have explained the complete parabola, and it is up to you now. You can solve some more PYQs here. And very important thing is you have to understand the concept first. That is the reason I have bring this Elevate batch for you. So that in this Elevate batch I have revised the entire parabola. And if you want any other type of videos, I can make, but you have to ask in the comment section. That's it for this video, guys. And if you like this video, subscribe to this channel and also hit the bell icon to get the notifications of the videos which I am going to release in the upcoming session. And another thing, guys, if you want to get the notes, of mine, I know my handwriting is not good, but if you want to want the reference, you can get this notes link in the Telegram channel, so you can get there. So the main important thing is you have to revise this chapter thoroughly in order to next to move to ellipse and hyperbola. So before moving to ellipse and hyperbola, you have to revise the parabola. That's it, guys. Keep learning, keep going. Thank you. Hello.